An important consideration by all pilots operating any size of aircraft is wake turbulence, which is simply the disturbance or vortex in the air left by a passing aeroplane. This air vortex can be very violent and can abruptly and violently disturb the aircraft's flight path. Fortunately, however, wake turbulence dissipates with time and distance from the aircraft. But nonetheless, longitudinal separation between aircraft is important, and minimum safety distances must be applied by air traffic control units to arriving and departing aircraft, so that this hazard can be avoided. Since the severity of wake turbulence is a factor of mass, ICAO grouped all aircraft by type and devised 3 wake turbulence categories according to the maximum certified takeoff mass of the aircraft concerned. The categories are illustrated here. Heavy, aircraft of 136,000 kilograms or more. Medium, aircraft of less than 136,000 kilograms, but more than 7,000 kilograms. And light, aircraft of 7,000 kilograms or less. Separation minima is applied to aircraft under the following circumstances. When 2 aircraft are using the same runway, either for takeoff or landing, whenever a following aircraft is at the same height as, or less than, 1,000 feet below the leading aircraft. Wake turbulence separation can either be based upon time, procedural separation, or distance when the aircraft is under direct radar control. However, most of this lesson will detail the procedural separation and not the radar-controlled separation. But brief mention of radar separation will be made when appropriate. The approach to land is a particularly important phase of flight, so we will now discuss the wake turbulence separation minima that will be applied to arriving aircraft. Remember, there are 2 types of wake turbulence separation. One procedural, being non-radar and based on time, and one based on the aircraft being under radar control, and thus based on distance. For non-radar separation, medium category aircraft, following a heavy category aircraft, must maintain 2 minutes separation minima. Light category aircraft, following a medium or heavy category aircraft, must maintain 3 minutes separation minima. Under radar separation, the following distances apply. For a heavy aircraft, behind a heavy aircraft, the separation is to be 4 nautical miles. For a medium aircraft, behind a heavy aircraft, the separation is to be 5 nautical miles. For a light aircraft behind a heavy aircraft, the separation is to be 6 nautical miles. For a light aircraft behind a medium aircraft, the separation is to be 5 nautical miles. Here are the tables of the radar and non-radar separation information to help your understanding. This completes wake turbulence separation for arriving aircraft. Next, we will look at wake turbulence separation for taking off and departing aircraft. Wake turbulence separation on departure is the minimum time for when the leading aircraft becomes airborne to the time when the following aircraft becomes airborne. However, not all departing aircraft take off from the same runway, and this adds a degree of complexity to the separation. Some airports have a number of runway systems, and wake turbulence can affect several runway operations. A minimum of 2 minutes separation is applied between a light or medium aircraft taking off behind a heavy aircraft taking off, or a light aircraft taking off behind a medium aircraft taking off. However, there are caveats to this. These are that the aircraft are using the same runway as shown here, or if they are using parallel runways separated by less than 760 meters, crossing runways, if the projected flight path of the second aircraft will cross the projected flight path of the first at the same altitude or less than 1,000 feet below it, parallel runways, which are separated by 760 meters or more if the projected flight path of the first aircraft crosses the second at the same altitude or less than 1,000 feet below it. As with the takeoff from an intermediary point, the separation minima changes on runways with displaced thresholds. Displaced thresholds basically mean that the start of the landings are not at the very beginning of the runway, but are displaced further along the runway length, as you can see here. There are two important parts of separation with displaced thresholds. The first relates to separation between aircraft taking off after another aircraft landing, and the second, which is the opposite scenario, relates to aircraft landing after aircraft taking off. For aircraft taking off behind landing aircraft using displaced thresholds, there is a 2-minute minimum separation. This separation applies to a light or medium aircraft taking off after a heavy aircraft has landed, and between a light aircraft taking off after a medium aircraft has landed. For aircraft landing behind another aircraft taking off using displaced thresholds, there is similarly a 2-minute minimum separation between a light or medium aircraft landing after a heavy aircraft has taken off and their projected paths cross. This separation also applies to a light aircraft landing after a medium aircraft has taken off. The last variation to the separation rules is when a takeoff and/or a landing take place in the opposite direction to other departing or landing aircraft. If a medium or light aircraft is attempting to take off in the opposite direction to a landing aeroplane on the same runway, and that landing aeroplane is heavier and initiating a missed approach, then the separation must be at least 2 minutes before the lighter aircraft commences the takeoff. Similarly, when a lighter aircraft is trying to land in the opposite direction to a heavier landing aircraft on the same runway, or even a parallel opposite direction runway less than 760 meters apart, and the heavier landing aircraft executes a missed approach, then a 2-minute separation minima must be applied before the light aircraft lands. In the last part of this lesson, we will examine the details of when wake turbulence separation is not required. The air traffic control unit concerned shall not be required to apply wake turbulence separation for any VFR arriving aircraft following a heavy or medium aircraft on the same runway. However, the air traffic control unit should issue a caution of possible wake turbulence. The wake turbulence separation in this instance now lies with the pilot of the following aircraft. The other occasion when an air traffic control unit is not required to ensure wake turbulence separation is when an arriving IFR aircraft is executing a visual approach, has the preceding aircraft in sight, and has been instructed by that air traffic control unit to maintain own separation. Again, in such an instance, the air traffic controller will issue a wake turbulence caution. This ends the lesson on wake turbulence separation. Hopefully, you have understood the importance of wake turbulence separation, and have also started to become familiar with the varying rules regarding wake turbulence separation.